Okay, good morning class. So we're looking at trigonometry. Yes. So at this point we have completed exercise 4. Okay. Completed exercise 4. Completed exercise 5. I know exercise 4 we didn't do, no? No, we did. Skipped exercise 4. So now we're looking at proving identities using compound double angles. Is that where we're at? Have we completed this year already? Just check there in your textbooks. There's nothing written here, so I assume that we are here now. Huh? This was homework for exercise 5. We are general solution, unit 4 now. Okay. And this is for exercise 6. And the exercise 6 on page 104. So we have dealt with general solution in grade 11, not so. Okay, remember when it's sine and cos, it's going to be k times 360, and if it's tan, it's k times 180. So that the rule still applies. Okay. So in grade 11, here we're told that in grade 11 you've learned how to solve trigonometric equations by finding the general solution, using it to find the specific solutions in the given interval. So next to the equation, if they give you an interval for which x is or an interval notation or an inequality, then we must find the solutions between those values. Okay. In grade 12, double and compound angles appears in the trigonometric equations. So now we're adding the compound and the double angles. Okay, you can solve these by substituting double angle and compound angle formula into the equation. Always find the general solution first and solve for specific solutions in the given interval only when required. Okay, so we're first going to go and solve the general solution with the trigonometric equation, and then we find the specific ratios in the given interval. And we've been doing that all the time already. Okay. So this is example 1, and example 1 is on page 102. 103. Okay. Alright. So we are asked to solve for x if 3 cos x minus 25 plus 2 is equal to 0, and x is greater than or equal to negative 360 but less than or equal to 360. So where do we start? We start by getting the trigonometric function on its own first. Okay, so we take that over. So it becomes 3 cos x minus 25 is equal to negative 2. What do I do thereafter? Divide by 3 both sides. So we have cos of x minus 25 is equal to negative 2 over 3. So what do we normally do at this point? What we normally do? We find our reference angle, not so. So we say reference x minus 25 is equal to r cos of 2 over 3. Although it is negative, I drop the negative here. Okay? So we go r cos, shift cos of 2 over 3 gives us 48, 19. That is 48, 19 degrees. Okay. So what question comes to mind, people? In which quadrant is cos? Negative. So it's all stations to Clement. Cos is negative in quadrant 2 and 3. So let's look at quadrant 2. How do we get in quadrant 2? It's going to be 180 minus. In quadrant 2 is going to be 180 minus, so we say 100, let's say the angle, which is x minus 25, is equal to 180 degrees minus 48,19 plus k times 360. Okay? So we take a 25 over the equal sign. I then say it's 180 degrees minus the answer of 48,19 plus 25. It's going to give you 156,81. So x is equal to 156,81 plus k times 360. Okay? Yes? Sorry? Plus minus? K? No. It's just minus plus k. Okay? And then in quadrant 3, how do you get into quadrant 3? It's going to be x minus 25 equals 180 plus 48,19 plus k times 360. So x works out to be 180 degrees plus 48,19 plus 25 gives us 253,19 plus k times 360, where k is an element of integers. Okay. Now coming back to that, to the restriction, okay, with the given interval. As you can see, the given interval is from negative 360 to 360 degrees. Can you see that? So what we say is, we say x is an element of, and we start listing. We use the one branch until it can't be used any longer. Okay? So when we start with k is equal to 0. So if k is 0, then it's going to be 156,81. If k is now 1, okay, then of course it's going to be over 360 degrees. Can you see that, people? Because that would have given you 151,81 plus 1 times 360 will give you an answer of 511,81. So you can see it's outside. So if 1 doesn't work, am I going to try 2 and 3 and so on? No. So now I go to the negative 1. So it's going to be plus negative 1 times 360. Okay, so that is negative 208,19. Is that within the given interval? Huh? Yes, so it's negative 208,19. So let's try negative 2. Negative 2. Negative 568,1. Is that outside or inside? Outside the given. Can you see that, people? Now that branch is exhausted, or can't be used any longer, so we go to the second branch, or the other one. So what do we say here? If k is 0, then it's going to be 253,19, which is in the given domain. If we're going to apply k to be 1, then it's going to be outside or over the 360 degrees. Can you see that, people? Now we try the negative 1. We say 253.19 minus 360, or plus 360 times negative 1. So It's going to give you negative 106,81. Negative 106,81. If we're going to try minus 2, we'll see that would also be outside or below this negative 360 mark. Okay, do you guys understand? Alright. Can I carry on? I'm moving too fast for your liking, too slow for your liking. Huh? Is it okay? Okay. This is example 2, and example 2 is on page 104. Example 2 is on page 104. So here we are told these examples uses double angles. The question says solve for x if 4 sine x cos x is equal to the square root of 3 and x is greater than or equal to negative 180 but less than or equal to 360 degrees. Okay. So where do we start? We start off by working out the general solution. We must first get the trigonometric ratio on its own. But if you look at 4 sine x cos x, what does this remind us of? Sine x cos x. The sine double angle, not so. But what is normally in front of it? A 2. So if I divide both sides by 2, I would now get a 2 in front of it. So it's going to be 2 sine x cos x equals the square root of 3 over 2. Do you all understand that? Now 2 sine x cos x can be written as what? Sine 2x. So sine 2x is equal to the square root of 3 over 2. So what do we do now? You're going to say arc sine, not so. So I work out my reference angle. As we know, that is a special ratio. So 2x is equal to 16. Let's say we didn't know that. We say reference 2x is equal to arc sine. So if we shift sine, we'll do 3 over 2. Arc sine square root of 3 over 2 gives me 60 degrees. Okay, so now we must do the general solution. People, do not divide by 2 at this point. Okay? You don't touch that angle until you've taken it to the quadrants. Okay, you guys understand? So, in which quadrant is sine? Positive. In which quadrant is sine positive? Quadrant 1 and 2. So how do we get into quadrant 1? Quadrant 1 is going to be 2x is equal to 60 plus k times 360 degrees. Or how do we get into quadrant 2? Quadrant 2, 2x is equal to 180 minus 60 plus k times 360. Where k is an element of integers. No? So what do I do now? Simplify. Okay. So I divide throughout by 2, so x is equal to 30 plus k times 180 degrees. Okay, but that is going to give me 120. 120 divided by 2 is 60 plus k times 180 degrees. Okay? So that is the if this wasn't the sum, if that wasn't asked for, then I would stop there. That's my general solution. Okay? You guys understand? But because there's a restriction or there's an interval or a given domain there, need to find out the solutions between negative 180 and 360. And where do we start? We say x is an element of, where do we start? Start with k is equal to 0. If k is equal to 0, then what do we get? We get the solution of 30 degrees, not so? If k is 1, this is 30 plus 1 times 180, so it's 210, which is still in that given domain. If k is 2, it's going to be 360 plus 30, which is 390, outside this given domain, the given interval, not so? So what do? We try now? Negative 1. So it's going to be 30 plus negative 1 times 180, so it's going to give you negative 150. We're going to go with negative 2. So they give you negative 360 plus 30, which is negative 330, which is outside the given domain. So I don't write it down. Does it make sense? So let's go on the other side, and then on this branch. If k is 0, then the answer is going to be 60 degrees, not so? Then we try 1. We try 1. So it's going to be 60 plus 1 times 180. So it's going to be 240 degrees, which is still within the given domain. Okay? But try 2 is going to give you 360 plus 60, which is 420 outside the given domain, or given interval. Now we try minus 1, because 2 doesn't work, 3 won't work, 4 won't work, and so on. Now try minus 1, so 60 minus 180 is going to give you negative 120. But try another negative, if I go with negative 2, it's negative 360, which gives me an answer of negative 300, which is outside the given domain. So that's where I stop. Okay? Any confusion, people? No? Example 3. Example 3 is on page. Example 3 on page 104. These examples uses compound angles, we are told. Give the general solution of this equation. Right, so what do we see here? We got sine 3x cos x minus cos 3x sine x. So which expansion is that? The sine or the cos expansion? From the sine. Why? Because for sine alpha minus beta becomes sine alpha cos beta minus cos alpha sine beta. So definitely sine expansion. So it's sine alpha minus beta is going to give me sine alpha cos beta minus sine beta cos alpha, or cos alpha sine beta. But what is in alpha's place? 3x. What's in beta's place? X. Can you see that? So in other words, when we reduce it, it's simply going to be sine of 3x minus. Can you guys see that, people? So that's going to give us sine 3x minus x is equal to 0, 4. If you work in reverse now. Okay? So what's 3x minus x? 2x. So sine 2x is equal to 0, 4. So what do we do now? What do we do now? We work the reference angle. So we say our reference angle is for 2x is going to give us arc sine of 0, 4. Okay? You say for arc sine of 0.4 gives us 23,58. 23,58 degrees. So what question comes to mind? In which quadrant is sine? Positive. And in which quadrant is sine positive? First and second. So let's go with quadrant 1. How do we go into quadrant 1? 2x is equal to 23,58 plus k times 360. For quadrant 2, how do we get in quadrant 2? 2x is equal to 180 minus. In that quadrant, 180 minus, 180 plus, or 360 minus. Okay? We never use 90 plus or minus out of our own. Okay? So in the second quadrant, it's going to be 180 minus 23,58 plus k times 360. Whenever you're busy with sine and cos, it's k times 360. Why? Because of the period of the sine and cos graph is 360, whilst the period on the tan graph is 180. Okay. So for quadrant 1, I'm going to divide throughout by 2. So x is equal to 23,58 divided by 2. Divided by 2 gives me 11,79. 11,79 plus, now 360 divided by 2 is going to give you k times 180. Okay, on the other side we got 180 minus 23,58. 25,8. That answer must be divided by 2. Gives me 78,21. 78,21 plus k times, and 360 divided by 2 is 180 degrees, where k is an element of integers. Okay. It's easily 5 marks in the assignments. Okay. Any confusion, people? No? Example 4. Example 4 is on page 101. 105. Example 1 is on page 105. Okay. Give the general solution of the equation. So what do we have to do first here? What do we have to do first? Find out LCM. So what's my LCM here? It's going to be cos 50, cos 40. Okay. So what must the first fraction be multiplied by? Cos 40. So it's going to be cos 2x, cos times cos 40, minus. What must that fraction be multiplied by? That denominator. Cos 50. That's going to be sine 2x cos 50 equals. Now remember, 0 over 0 can be written as 0 over 1. Okay? So this denominator must be multiplied by cos 50 cos 40. So you multiply your numerator by the same value, it's going to give you 0. Not so. Alright. So people, what does this now remind us of? Cos, sine. But this needed to be a sine if you're going to look at the cos. Not so. So cos 50 can be written as sine of something. It can be written as sine of what? Sine of 40. Alright, good. Or you can write it firstly as cos of 90 minus 40. So 90 minus 40 is of course 50. And 90 minus changes cos to sine. So it's sine 40. Sine 2x. We got cos 2x, cos 40. Equals 0. So now the cos expansion, if it's got cos alpha plus beta, is equal to cos alpha cos beta minus sine alpha sine beta. Okay, and that is the identity here. What is in alpha's place? What's in alpha's place? 2x. What's in beta's place? 40. So So in other words, it's going to be alpha is 2x and your beta is 4. That is what you must be able to see in your mind. Okay, in your mind. Your mind's eye. Otherwise, you can write it out like this as I'm showing you, this straight into you. So this can be written as cos of 2x plus 40 is equal to 0. So what do I do now? I work out my reference angle. Or because it's 0, 1 or minus 1, one of those values I take it to the graph. I know some of you do it without the graph. I just feel safer with the graph, okay? This is the cos graph. That's normally 360 degrees on the cos graph. Okay. Now, where is cos of the graph equal to 0? Where is y equal to 0? At 90 degrees and 270. Can you see that? So you can write this as 2x is 2x plus 40 equals 90 degrees plus k times 360, or 2x plus 40 is equal to 270 degrees plus k times 360. Okay? So again, it's going to be 2x plus 40 is equal to, for the first one, 90 degrees plus k times 360, or for the second one, it's going to be 2x plus 40 is equal to 270 plus k times 360. You can do it like that, or we will note that this actually happens every, how many degrees is that? Every 180 degrees, this will happen. Okay, that's where the graph will come down again and so on. So that will happen every 180 degrees. So you can write it as 1 as 2x plus 40 equals 90 degrees plus k times, since it's happening every 180 degrees. Okay. So what we're going to do is we're going to take out over the equal sign. So 2x is equal to 90 minus 40 is 50 degrees plus k times 180 divided by 2. X is equal to 25 plus k times 90 degrees. Okay. But if you had written both branches, you'd get the full mark anyway. Okay. Is that your sister? Huh?
No, sir. I think the same grade.
Huh?
I think the same grade.
Twins?
Now you're pushing it, sir.
With that thunder, I thought she was standing here now. Okay. People, any confusion here? You want me to write the other branch out? You understand? Yes, I write it out. Okay. If I had gone with the other, with representing each one, then you would have simply have been, the first one would have been 2x plus 40 equals 90 plus k times 360. Remember that k is an element of integers, no? We don't fill that in, you lose a mark. So you take that over the equal sign, so 2x is equal to 90 minus 40, which is 50, plus k times 360, divided by 2, is going to give you 25 plus k times 180. Okay. K times 180. Okay. Or the other one, which is going to be at the 270 degrees. So it's going to be 2x plus 40 equals 270 degrees plus k times 360. So 2x is equal to 270 minus 40 is 230 plus k times 360 divided by 2 is going to give you 115. 115 plus k times 180. Where k is an element of integers. Okay. If you don't see that it can be written as 90 plus k times 180, you can write both branches, you'll still get the full mark. Okay, you guys understand? And this is now the examples for the next exercise, correct? Okay. So for homework, I would like you guys to complete exercise 6 on page 105. Okay?